In this lesson today, we're going to learn how to calculate molar mass. By the end of this, you should be able to calculate molar mass and calculate molecular mass. First thing we're going to start with is molecular mass. Remember those atoms that we counted in the last lesson? Well, here's how they're going to be used. We're going to calculate the molecular mass of one molecule of a compound. So the first step to do this is to count how many atoms of each element are present. We know how to do that, so we look at the subscripts, see that we've got a 2 after Al, Al is aluminum, and a 3 after S, and S is sulfur. So that must mean we have 2 atoms of aluminum and 3 atoms of sulfur. All right, first step done. So the next step then would be to multiply the number of atoms by the element's atomic mass. We know that aluminum has 2 atoms because we've figured that out and we've looked at the subscripts, and we know that sulfur has 3 atoms. Now we need to figure out the mass of each of these. Looking at the periodic table, aluminum's mass is 26.9. We are going to round to 27. And the unit for this is going to be AMU over atom. AMU stands for atomic mass unit, and it's used when we're dealing with really tiny masses. All right, so let's take 2 times 27, and we will get a mass of 54 AMU for aluminum. One thing you will notice is that I don't have atoms on there anymore, because if you remember in math class, when you take 1 divided by 1, they equal 0. So essentially you just cancel them out because you know that they equal 0. And that number is not really significant. The same case goes here. If you extend the division line, you see that atoms are on the opposite side of the division line. So they're going to cancel out. And I am left with AMU. All right, let's do the next one. So sulfur's atomic mass is 32. AMUs over atoms. So let's take 32 times 3, and we've got 96 AMU. This step is done. The last thing we have to do in order to calculate molecular mass is to add up the masses that we had just calculated for each of the elements. We calculated that aluminum's was 54 AMUs and sulfur's was 96 AMUs. So all I need to do is add these two together, and I will get 150 AMUs of aluminum sulfate. All right, let's do an example. I want to figure out the molecular mass of BF3. Remember, first step is to figure out how many atoms we have. Boron, we're looking at that and we see there is no subscript, so that means we have 1 atom. Fluorine, we look and see that we have a 3 there, so that means we have 3 atoms. Well, now we have to calculate the mass of each element. Boron's mass is 10.8, so I'm going to round that up to 11. And we know 11 times 1 gives us 11. For fluorine, our mass is 18.9. We're going to round that to 19. 3 times 19 gives me 57 AMU. Now I need to add these two together, and I have a total of 68 AMU BF3. All right, so let's now talk about calculating molar mass. We're going to go through the same steps as calculating molecular mass. At first, we're going to count how many moles of each element we have and then multiply that by their molecular mass. So, the thing to note here is that when we're calculating molar mass, we're calculating a mass that we can physically see. We're dealing on a larger scale than we are with molecular mass, and we're dealing with multiple molecules of something instead of just one. So just like finding how many atoms are in each element, we are going to look at the subscripts to figure out how many moles are in those elements. For calcium, we see that there is no subscript there, so that means we have 1 atom of calcium. And let's go ahead and multiply that right now. Calcium's mass is 40. And when we're doing it on a larger scale, our unit is grams per mole. Here we go. So we have 1 mole of calcium, and we're going to multiply it by 40 grams per mole. Moles cancel out, and we are left with 40 times 1, which gives us 40 grams. All right, let's try bromine now. Bromine, we see that we have a 2 here, so that means we have 2 moles of bromine. Bromine's mass is 79.9. We're going to round that up to 80 grams per mole. 80 times 2 is 160 grams. All right, first step done. Now, we're going to take those masses and add them together. So for calcium, we had 40 grams. Bromine, we had 160 grams. So this gives us 200 grams of calcium bromide. Let's try an example. In this example, we have copper oxide. And first steps first, we need to identify how many moles that we have. It looks like for copper, we have 2 moles. And oxygen, we have 1 mole. Now we have to multiply them by their molecular mass. Copper's molecular mass is 63.5, so we'll round that to 64. And oxygen's molecular mass is 15.9, so we're going to round that to 16. Now let's do the math. First, let's start with copper. We're going to take 2 times 64, and that'll give us 128 grams. 1 times 16, well, that gives us 16 grams. Finally, for the very last step, we're going to have to add these together. So after adding them together, you should get 144 grams of copper oxide. All right, let's try another example. This time we have potassium phosphate. First steps first, we're going to identify how many moles we have. And it looks like here we have 3 moles of potassium. We have 1 mole of phosphorus and 4 moles of oxygen. Now we have to multiply them by their molecular mass. Potassium's mass is 39. Phosphorus's mass is 31. And oxygen's mass is 16. Now we got to do the math. So let's take 3 times 39 to do potassium first. And it looks like we're going to get 117 grams. Now let's do phosphorus. 1 times 31, that gets us 31. And finally, let's do oxygen. Take 4 times 16, and that gets you 64 grams. The very last step should be to add all of these together. So we're going to take 117 plus 31 plus 64, and you should get about 212 grams of potassium phosphate. I have one more example here that I would like to go through, just because this one's a little bit more tricky than it would be if you were to try it on your own at first, and you may figure it out right away, and that's great. First things first, remember we have to identify how many moles we have, but if you notice we've got parentheses here. So this 3 outside the parentheses, we're going to FOIL it just like we did when we were doing the coefficient and figuring out the atoms like this. And we went and we FOILed it, and then we ended up with 6 and 3. Well, we're going to do the same thing. We're going to FOIL this to the subscripts inside the parentheses. So we're going to end up with 3 times 1 and a 3 times 4. For aluminum, it looks like we have 2 moles. For sulfur, this is going to be 3 times 1 because we had to FOIL that in. It's still going to, we're going to get 3 moles from that. And then oxygen, that is going to be 3 times 4. So we're going to have 12 moles. Now we have to calculate the mass of each of the elements. We've got a mass of 27 grams for aluminum. For sulfur, we have 32. And for oxygen, we have 16. Now let's do the plug and chug math. We've got 2 times 27 for aluminum. That gives us 54 grams. 3 times 32 for sulfur. This gets us 96 grams. And 12 times 16 for oxygen, which gets us 196 grams. I'm sorry, 192. Last step, add them all together. So let's take 54 plus 96 plus 192, and that'll get us 342 grams of Al2SO43.